New 2018 Marine Aviation Plan seeks to keep the Osprey cutting edge and effective against new threats until 2060. The Marine Corps is accelerating a massive modernization and readiness overhaul of its MV-22 Osprey to upgrade sensors, add weapons, sustain the fleet and broaden the mission scope, as part of an effort to extend the life of the aircraft to 2060. We plan to have the MV-22B Osprey for at least the next 40 years, Captain Sarah Burns, Marine Corps Aviation spokeswoman, told Warrior Maven. While first emerging nearly 2 decades ago, the Osprey tilt-rotor aircraft has seen an unprecedented uptick in deployments, mission scope and operational tempo. As a result, Corps developers explain that the aircraft has, to a large extent, had trouble keeping pace with needed modernization and readiness enhancements. This challenge has been greatly exacerbated by a major increase in Combatant Commander requests for Ospreys, particularly since 2007, Corps officials say. The quality of maintenance training curricula, maturation, and standardization has not kept pace with readiness requirements. Current maintenance manning levels are unable to support demands for labor. The current V-22 sustainment system cannot realize improved and sustained aircraft readiness availability without significant change, the Corps writes in its recently published 2018 Marine Aviation Plan. Depot-level maintenance cannot keep up with demand. Given this scenario, the Corps is implementing key provisions of its Common Configuration, Readiness and Modernization (CCRAM) plan which, according to Burns, is designed to achieve a common configuration and improve readiness to a minimum of 75% mission-capable rate across the fleet. Corps officials said the idea with Osprey modernization and sustainment is to build upon the lift, speed and versatility of the aircraft's tilt-rotor technology and give the platform more performance characteristics in the future. This includes arming the Osprey with rockets, missiles or some kind of new weapons capability to support its escort mission in hostile or high-threat environments. Other elements of Osprey modernization include improved sensors, mapping and digital connectivity, greater speed and hoverability, better cargo and payload capacity, next-generation avionics and new survivability systems to defend against incoming missiles and small arms fire. The 2018 Marine Aviation Plan specifies that the CCRAM program includes more than 75 V-22 aircraft configurations, identified in part by a now completed MV-22 Operational Independent Readiness Review. CCRAM calls for improvements to the Osprey's multispectral sensor, computer system, infrared suppressor technology, generators and landing gear control units, the aviation plan specifies. As part of this long-term Osprey modernization trajectory, the Marines are now integrating a command and control system called Digital Interoperability, DI. This uses data links, radio connectivity, and an Iridium antenna to provide combat-relevant intelligence data and C4ISR information in real time to Marines, while in flight on a mission. In addition, the Osprey is being developed as a tanker aircraft able to perform aerial refueling missions. The idea is to transport fuel and use a probe technology to deliver fuel to key aircraft such as an F/A-18 or F-35C. The V-22 aerial refueling system will also be able to refuel other aircraft such as the CH-53EK, Aviate-B Harrier jet and other V-22s, Corps officials said. Fielding of the full capable system will be in 2019. This system will be able to refuel all MAGTF, Marine Corps Air Ground Task Force, aerial refuel-capable aircraft with approximately 10,000 pounds of fuel per each VARS-equipped V-22, the 2018 Marine Aviation Plan states. Due to its tilt-rotor configuration, the Osprey can hover in helicopter mode for closed surveillance and vertical landings for things like delivering forces, equipment and supplies, all while being able to transition into airplane mode and at fixed-wing aircraft speeds. This gives the aircraft an ability to travel at 450 nautical miles to and from a location on a single tank of fuel, Corps officials said. The Osprey can hit maximum speeds of 280 knots, and can transport a crew of Marines or a few Marines with an internally transportable vehicle. Corps developers also emphasize that the V-22 modernization effort will incorporate new technologies emerging from the fast-moving Future Vertical Lift program. This could likely include the integration of newer lightweight composite materials, next-generation sensors and various kinds of weapons, C4ISR systems and targeting technologies. Fast-moving iterations of artificial intelligence are also likely to figure prominently in future V-22 upgrades. This could include advanced algorithms able to organize and present sensor data, targeting information or navigational details for Marines in flight. While the modernization and sustainment overhaul bring the promise of continued relevance and combat effectiveness for the Osprey, the effort is of course not without challenges. The Corps plan cites concerns about an ability to properly maintain the depot supply chain ability to service the platform in a timely manner, and many over the years have raised the question of just how much a legacy platform can be upgraded before a new model is needed. Interestingly, as is the case with the Air Force B-52 and Army Chinook, a wide-ranging host of upgrades have kept the platforms functional and relevant to a modern threat environment for decades. The Air Force plans to fly its Vietnam-era B-52 bomber while into the 2050s, and the Army's Chinook is slated to fly for 100 years, from 1960 to 2060, according to service modernization experts and program managers. The common thread here is that airframes themselves, while often in need of enhancements and reinforcements, often remain viable if not highly effective for decades. The Osprey, therefore, by comparison, is much newer than the B-52 or Chinook, to be sure. This is a key reason why Burns emphasized the common aspect of CC/RAM, as the idea is to lay the technical foundation such that the existing platform can quickly embrace new technologies as they emerge. This approach, widely mirrored these days throughout the DoD acquisition community, seeks to architect systems according to a set of common, non-standards such that it helps establish a new, more efficient paradigm for modernization. At the same time, there is also broad consensus that there are limits to how much existing platforms can be modernized before a new aircraft is needed. This is a key reason why the Army is now vigorously immersed in its Future Vertical Lift program which, among other things, is currently advancing a new generation of tilt-rotor technology. Furthermore, new airframe designs could, in many ways, be better suited to accommodate new weapons, C4ISR technologies, sensors, protection systems and avionics. The contours and structure of a new airframe itself could also bring new radar signature reducing properties as well as new mission and crew options. Navy Osprey. In a concurrent and related development, the Navy is working on its own MV-22B Osprey variant to emerge in coming years. The project has gained considerable traction ever since the service decided to replace the C-2 for the important Carrier on Board Delivery (COD) mission with the Osprey. The Navy Osprey is designed to enable 1,150 miles of flight to the ship with extended fuel tanks. Alongside a needed range increase, the new aircraft will also include a new radio for over-the-horizon communications and a built-in public address system, service officials said. The new Osprey, slated to first be operational by the early 2020s, will perform the full range of missions currently executed by the C-2S. This includes VIP transport, humanitarian relief mission and regular efforts to deliver food, spare parts and equipment for sailors aboard carriers. The Navy Osprey variant will take on a wider set of missions than those performed by a C-2. Helicopter or tilt-rotor carrier landings do not require the same amount of preparation as that needed for a C-2 landing. There is no need for a catapult and a tilt-rotor naturally has a much wider envelope with which to maneuver.